Hello everyone, this is Ma'am Amano and this lecture video is all about the history of atomic theory or the atomic model. So on our present day, we can define atom as the most basic and simplest foundation of our matter or everything around us. Let us start this topic with Democritus and Deuseppus being them the first person who proposed the idea of atoms. It is thought that Deuseppus is the first one who proposed the idea of atom, but then Democritus coined the term atom from the Greek word atomos, which means uncuttable. You cannot, according to him, you cannot cut it, you cannot split it, or in any means. But we already know now that the idea of the atom being uncuttable or unsplittable is wrong, right? We have known that in our present time. The idea of Democritus and Deuseppus in terms of atom or the idea of atom was strongly condemned by Aristotle and Plato. Because Aristotle is one of the most influential person back then as an influential philosopher alongside with Plato. He is the most prominent. So Aristotle did not believe in the atomic theory and he thought so otherwise. He thought that all materials on earth were not made of atoms but of the four elements earth, fire, water, and air. He believed all substances were made of small amounts of these four elements of matter. So since Aristotle has many followers back then, a lot of people ignored Democritus and Deuseppus. So their idea was automatically rejected by a large group of people back then in Greece. But then we have here Lucretius who recorded the idea of Democritus, and therefore the idea of atom has survived during the Dark Ages for future consideration. Then Antoine Lavoisier in 1789 proposed the law of conservation of mass or discovered the law of conservation of mass through a vacuum. So according to him, the law of conservation of mass is that mass can neither be created nor destroyed. Then we have here Joseph Louis Proust. In 1799, he proposed the law of definite proportions, which states that masses of elements in a compound always occur in the same proportion. So what is the meaning of the two? And these two laws here, the law of definite proportions and the law of conservation of mass, greatly contributed in the atomic theory or the development of atomic theory. First, we have here, for example, when you are balancing a chemical reaction or a chemical equation. We always balance a chemical equation. As you can see here, this is not balanced because we have here 3 carbons, 1 carbon, then hydrogen here 8. On the product side, we have 2, oxygen here 2, then on the product side, we have here 3. So, this is not a balanced one. We are balancing a chemical equation so that we will abide in the law of conservation of mass. That whatever the mass in the reactants must be the same on the mass of the product. So, to do that, you should obtain the same number or the same number of pieces of the elements. So, to balance this one, you will put a 3 in the carbon coefficient here. Let me use another color. Okay, so you will put 3 here to balance that. Then, you have a subscript here, right? An imaginary 1. So, 3 times 1, that is 3 carbon here. Then, you will have the same one here. Then, since from the previous here, you only have 2 pieces of hydrogen. So, you will add 4 on the water coefficient. Adding 4 on that. Magdadagdag ka ng 4. 4 times the subscript 2, that is 8. Then, same na sila. Then, for oxygen, you have here, if you will count on that, that is 4. 4 times 1. 4 plus, and then 3 times 2. 2 times 3. That is 6 plus 4, that is 10 oxygen rather. So, the reason why we are balancing a chemical equation so that it will abide on the law of conservation of mass, that mass can neither be created. Kapag nag-react na yung mga elements, hindi sila mawawala yung mga masses nila. The products will have the same mass. So, that is why we are balancing a chemical equation. To prove that mass can neither be created nor destroyed. It is conserved. Then, we also have here the law of definite proportions. The masses of elements in a compound always occur in the same proportions, meaning to say in the same number of pieces. For example, you have here your sodium chloride. Sodium chloride, the proportion of that is 1 sodium, 1 chlorine. Okay? So, if you will add 2 here, this is no longer at table salt or di na yan asin ngayon because the chemical formula for table salt is sodium and chloride, 1:1 ratio. The proportion is 1:1. So, if you will have a 2 in the chlorine subscript, therefore, this is no longer a sodium chloride. This is therefore a sodium dichloride, which is a type of gas. This will be a type of gas. And then, what are the other examples that I can give you? For example, the water. So, for water, you have your H2O, right? Meaning to say 2 pieces of hydrogen and then 1 pieces of oxygen. If you will add here a 2 on the oxygen, in the molecule of H2O, that will be hydrogen peroxide, and that is poisonous. This is no longer a water. So that is the meaning of law of definite proportions. It means that all water molecules have the same molar mass. That is the meaning of that. Then, as I have mentioned, many people back then neglected the idea of Democritus and Leucippus because it was strongly condemned by Aristotle and Plato. After 2,000 years, Sir John Dalton proposed the first atomic theory. What we have here, don't be confused, we only have here the idea. They got the first idea from here. First idea. But then John Dalton proposed the first atomic theory, which is known as law of multiple proportions. He called his first model of atom as billiard ball model of atom. It became the first atomic theory in the scientific community when he first presented his oral presentation in 1803, which is his thesis, and then it was published in 1805. Law of multiple proportions states that ratios of masses of elements in a compound are small whole numbers, and each chemical element consists of single type of atom that cannot be destroyed by any chemical means. When you are doing chemical balancing, you often express, di ba? Ini-express ninyo into simplest form. That is the thought of law of multiple proportions here. You have to express your chemical balance equation into its simplest form and in whole numbers, not in decimal or numbers having decimal points. So it must be in whole numbers. And that is true until today. But then, the only lapse of the law of multiple proportions is that it cannot be created by any chemical means. We all know now that we can split atoms. So, his model of atom is also known as billiard ball model of atom. So, from the billiard, if you have seen a billiard ball, di ba bago laruin yung billiard ball, tinitimbang muna para parehas. So, according to him, ang mga element ng mga chemicals from a certain compound ay pare-parehas ng mass. Okay? Para-parehas ng property. For example, lahat ng sodium ay para-parehas ng property. Lahat ng chlorine ay para-parehas ng property. At para-parehas sila ng mass. So, that is his idea of billiard ball model of atom. Then after that, after the billiard ball model of atom, came Sir J.J. Thomson. He proposed the plum-pudding model of atom and he discovered electron through the cathode ray tube experiment. Okay, I have here a cathode ray. So this one is a cathode ray tube, meaning to say it's like a fluorescent, para siyang salamin ng bombilya or ng salamin ng ilaw ninyo. So this is important, yung mga fluorescent natin sa bahay, yung mga ilaw. Importante yun para yung mga chemical reactions na ini-emit ng mga battery or ng mga radiation from there ay natatrap lang dun sa loob. So, that is the importance of fluorescence in a cathode ray tube. And then, meron tayo ditong negatively charged metal plate. Ito yung ginamit niya sa experiment. And then, positively charged metal plate. So, dito nag-inject siya ng electricity. Electricity. Anong meron sa electricity? Electrons. So, ang charge ng electricity ay negative. So, ang observation niya, nung nag-inject siya ng high volt of electricity, the electricity rushed upward instead of going downward. So, he came up with the idea that there is an attraction between the positive and the negative. Since this is a positive plate, okay, the electron therefore is a negative one. Okay? So, ang basis niya dito ay yung magnets. Diba? Sa magnets, opposite poles attract, north and south attract, west and east attract. Then, nire-repel nila yung like poles. North to north, nire-repel nila. South to south, nire-repel ng magnet. Then, west to west, nire-repel ng magnet. East to east, nire-repel ng magnet. So, from there, from the law of the attraction in the magnets, in which like poles repel each other, unlike poles attract each other, he came up with the idea that the electron is a negative one because it attracted on the positively charged metal plate. Ito yung structure ng atomic model niya, plum-pudding model. So dito, itong bilog na to, itong mga pula na yan, itong pulang plate na yan, yan ay positively charged metal plate. And then, itong mga nasa ibabaw, yan ay ang electron na according to him ay unevenly distributed on the top of the metal positive plate, according to him. So, parang ganito. Meron tayo ditong ball of positive charge, tapos andito yung negative electron. Ayan, sa ibabaw yung blue. Or, para yung chocolate chip cookie, yung brown na to, ayan yung positively charged metal plate. Tapos yung cookies, yung chocolate cookies dyan, yan yung negatively charged electrons. Pwede rin yung watermelon, yung pula yung positively charged metal plate, and then yung mga buto, yung ating negatively charged electrons. Or, parang pudding. Ito yung pudding na binases, kung saan siya nag-basis ng model niya, or nag-base ng model niya rather. Yung brown, yun yung positively charged metal plate, tapos yung mga tuldok-tuldok na yan yung electrons na negatively charged. So, yun yung model ni J.J. Thomson. Next came Ernest Rutherford. Si Ernest Rutherford ang nakadiscover ng proton. He proposed the nuclear model of atom through the experiment of gold foil experiment or alpha scattering experiment. Paano niya ginawa yung experiment? We have here the alpha source of alpha particles. Ang charge ng alpha ay positive. And then we also have here the circular fluorescent screen, again to enclosed or encased or to vacuum the radiation that will came from the alpha rays. We also have here the thin gold foils. And then, ang ginawa ni Rutherford, nagpakawala siya ng alpha particles dun sa thin gold foil. Tinarget niya yung center ng gold foil. So, ang challenge niya, kung totoo yung idea ni J.J. Thomson regarding the electrons na uneven na naka-scattered dun sa positively charged plate, parang ganito, dapat nung nagpakawala siya ng alpha charge, kasi ang charge ng alpha particles ay positive, right? Tapos yung electrons ay negative, tama? So, ang mangyayari dyan, dapat magpapass through lang yung rays, yung alpha rays, kasi ma-attract siya dun sa negatively charged electrons. So, dapat magpapass through lang siya. Yun yung challenge ni Rutherford. But then, ang nangyari, yung ibang particles ay nag-pass through. Again, positive ang alpha, negative ang electron. So, positive to negative, it will attract. Opposite signs attract. Yung iba nag-pass through, but then, yung iba nag-deflect at the center. Ibig sabihin, bumanda lang. Ito, hindi siya automatically nag-pass through, nag-angle deflection siya. Kumbaga, hindi siya nag-pass through, kundi, pagbangga niya doon, nirepel niya yung nasa gitna. So, ang conclusion ni Rutherford, since nirepel niya yung nasa gitna, mayroon ditong same charge, kumbaga na nasa gitna. Yun yung tinatawag nating positive-positive. Since hindi siya na-attract dun sa gitna, hindi siya nag-pass through, dapat mag-pass through lang siya. Ang nangyari, nag-deflect siya ng direction. So, dun na isip ni Rutherford na mayroong positively charged particle dun sa gitna ng atom. Kasi nirepel niya yung substance or yung alpha rays. Again, positive, or negative, same signs repel each other, or like signs repel each other, like poles repel each other. Opposite signs, opposite poles attract each other. Ito yung law na ina-apply natin dito. So, parang ganito sa experiment niya. Ang nangyari, yung alpha rays nag-pass through, but then yung iba nag-deflect away from the center. Ibig sabihin, hindi siya na-attract dun sa center, and then therefore, hindi siya makakapag-pass through dun sa thin gold foil. Kaya dun niya rediscover yung proton na positively charged particle. Ayan. Okay, yun ang comparison natin dito. Ito yung nuclear model ni Rutherford. Dito sa gitna yung ating proton. Hindi nucleus because during that time, hindi pa na-discover ang nucleus. So, alam lang nila na merong very massive particle na nasa gitna na positively charged. And then, we also have here the electrons na negative. Ayan. So, dito, dinisprove ni Rutherford that the plate here is all positively charged plate na tapos toppings lang yung electrons. Sabi niya, concentrated sa gitna, sabi ni Rutherford, concentrated sa gitna yung positively charged particle o protons. Again, wala pang nucleus sa time na to. Hindi pa na-discover si neutron. Okay? Next came the Niels Bohr, 1913. Si Niels Bohr ang nag-propose ng planetary model of atom at yung ating very famous na electronic configuration. Sige, pag-usapan natin to. This is the Bohr model of atom. Ang concept lang nito, kinontest according to Niels Bohr because during those time people are looking for order. They are not looking for random order, but they are looking for strictly a law that challenge the order of many things. So, according to him, hindi pwedeng nagkakalat ang electron. Okay? So, ang ginawa niya, nagpropose siya ng idea na kung saan ay parang heliocentric model. May mga orbits yung mga electron, parang ganito. Nasa gitna yung proton, and then may mga orbits, which is opposite dun sa mga previous model. May mga orbits, tinawag yung planetary model of atom because it resembles the planetary system or solar system that we have. We have here the proton, and then the planet serves as the electron orbiting their specific orbits. So, according to Bohr, dapat may orbits yung mga electrons. Parang hagdan daw. Hindi ka pwedeng umapak or mag-jump. Hindi ka pwedeng mag-jump dito sa part na to. Instead, the electrons must have a specific step. Pwedeng humakbang pataas, but then never in between. Kapag nag-level up ang atom, nagkakaroon ng excitation, ito yung nagre-release sila ng energy. Kapag nakalipat siya ng orbit or ng step dun sa stair. Pero never na maglaland dito sa in-between. Kaya di ba, hindi nyo pa na-try umapak dito? lagi kayong maapak sa part na to ng hagdan. Hindi pa dun sa pinakagilid niya. Right? So, yun yung concept ni Niels Bohr in terms of planetary model. Next, we have here the electron configuration of Niels Bohr. Ito yung product ng planetary model niya. We have here first, on the first shell, it can only hold 2. Second shell, it can only hold 8. Then next, add mo lang yung exponent 10 plus 6 plus 2, it can hold up to 18. Then yung kasunod, 14 plus 10 plus 6 plus 2, that is 32, yung next shell. Kapag nagbabasa kayo nito, sundan nyo lang yung arrow, alternating arrow. You have here 1s2, 2s2, 2p6, 3s2, then 3p6, 4s2, and so on, so on, so on, so on. Pag nagbabasa kayo. Okay? And then, pag magsusulat kayo ng electron configuration, nakadepende yung exponent ninyo dun sa number of electrons. So, for example, I have here fluorine. Ang atomic number niya ay 9. Therefore, meron siyang electron number of 9. So, pag maglalagay ka ng electron sa shell niya, pag mag-drawing ka, ang first shell, again, ang limit niya ay 2 electrons. So, meron kang 2 electrons dito. Then, yung second shell, ang limit niya ay 8 electrons. But then, meron ka lang ditong 7. 3, 6, 7. Pwede siyang maging kulang ng 8, pero bawal siyang sumobra. 7 lang kasi kapag i-add mo yan, 7 plus 2, 7 plus 2, that is 9. Yung nasa gitna, ano yan, proton, di yan kasama sa binibilang. So, 7 plus 2 is 9, corresponds to the number of atomic number that we have here. Kapag isulat mo naman yung electron configuration niya, yung this one, ang pagsusulat niyan, depende dun sa exponent at saka dun sa sequence. Una, 1s2, 2 electrons here. Then, susundan siya ng 2s2, 2 electrons here. That is 4 already, 4 electrons. Then, instead of writing 2p6, you will write only 2p5. Because you only have 9 electrons. The fluorine has only 9 electrons based on the atomic number. So, that is 1s2, 2s2, and 2p5. Okay. 5 plus 2 plus 2, that is 9, corresponding to the number of electrons. So, ayan, 1s2, 2s2, 2p5. Ganyan lang. Another example, we have here bromine. Si bromine, ang kanyang atomic number ay 35, therefore, meron siyang 35 electrons. Again, ang unang shell, ang limit niya ay 2 electrons. Ang sunod na shell, ang limit ay 8 electrons. Kung bibilangin mo, 8 yan. 1, 2, 3, 4, 5, 6, 7, 8. Then, yung next shell, ang limit niya ay 18 electrons. So, meron ka dyang 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then, yung next shell, ang limit niya ay 32 electrons. Pero hindi ka maglalagay ng 32 dyan dahil dapat ito-total mo lang siya kung ilan ang number ng electrons ng bromine, which is 35. Pag magbibilang ka, 18 plus 8 plus 2, that is how many? You only need 7 here. 1, 2, 3, 4, 5, 6, 7 to correspond for the 35 electrons. So, that is 2 plus 8 plus 18 plus 7. That is 35 electrons here. Okay? So, kapag magsusulat ka ng electron configuration dito, ang gagawin mo lang, again, by sequence and by exponent. So, that is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p5. Pag i-add mo, not 4p6 because you only have again 35 electrons. Para malaman mo kung tama ka, i-add mo yung exponent niyan. 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 10 plus 5 instead of 6. That is 35 electrons corresponding to the number of electrons of bromine, which is 35. Ayan, 3d10 and 4p5. Next, another example, we have here aluminum. The atomic number of aluminum is 13. Therefore, it has a 13 electron. Or electrons rather. So, ang distribution, depende dun sa limit ng shell. Yung unang shell, ang limit niya ay 2. Ang kasunod ay 8. And then, 13 lang ang kailangan mo. So, hindi mo kailangan punuin yung 18 na limit ng electron dito or max limit ng electron. So, ang lalagay mo lang 2 plus 8, that is 10. So, 13 lang yung aluminum. Drawing ka lang dito ng tatlong electron. So, that is 13. Correspond 2 plus 8 plus 3, that is 13, corresponding to the number of aluminum electron. Then, kapag magsusulat ka ng electron configuration ng aluminum, bilangin mo exponent per shell. 1s2, 2s2, 2p6, 6, 7, 8, 9, 10. That is already 10. So, 3s2. And then, 3p. Okay. Kahit wala ng 1 sa exponent, okay lang yan. So, pag inad mo yan, that is 2 plus 2 plus 6 plus 2, that is 13. Corresponding to the number of aluminum electrons. Ganun lang. So, ito yung mga, pag nag-search kayo ng planetary model of atom, ito yung lumalabas sa net. This is wrong because during that time, wala pang nucleus dahil proton pala yung nanoon. Hindi pa na-discover yung neutron. So, this is wrong. And ito, planetary model of atom, this is wrong as well because during that time, wala pang neutron. So, this is wrong as well. And this is wrong as well because wala pang nucleus noon. Ang mayroon lang noon ay proton. And that should have been proton instead of nucleus dahil wala pang neutron nun. Okay? Kasi ang nucleus ay combination ng proton at neutron. Right? During that time, hindi pa na-discover ang neutron. So, ito yung accurate representation ng planetary model, proton, and then the electrons containing on their orbits or revolving within their orbits. But then this one is already wrong or outdated model. We all have here the latest model of atom based on the principles of Werner Heisenberg and Schrödinger. It is anchored on uncertainty principle. The model of atom that he proposed and is currently being used worldwide is quantum mechanical model of atom or electron cloud model of atom. So what is uncertainty principle? It says that you cannot predict or you cannot tell exactly what is the location of your electron. And what is its direction? You cannot exactly tell that. We have here the electron cloud model, but then this is wrong. This nucleus here, that should have been proton instead of nucleus because during that time, hindi pa na-discover si neutron. So, wala pang nucleus ng proton lang. But then, since it is the currently accepted model, we can put the nucleus here. You have here the proton and then electron cloud, fuzzy electron cloud. It means that is blur. You cannot tell the exact location of the electrons and its direction as well as momentum. So, parang ganito rin yan. Ito yung nucleus or proton dito sa gitna. Tapos, may fuzzy dyan or blurry. Hindi mo malalaman yung exactong location ng electron. So, for example, para yung fog, nasa foggy location ka. Let's say may dalawang tumalbog na bola. Na malalaman mo kung ilang perasong bola yung tumalbog, but since it's very foggy, you cannot tell its exact location. Para rin yung sunny side up ito yung proton sa gitna, and then yung fuzzy fog natin ng electron ay itong puti, you cannot tell exactly kung nasaan yung electron. So for example, you have hydrogen. The hydrogen has a 1 electron. Andito yung proton sa gitna. Pero yung nag-iisang electron niya, hindi mo malalaman kung nasaan siyan. So, dinidebunk nito yung planetary model ni Niels Bohr. Ito yung currently accepted model. Tapos, for example, oxygen. Ang atomic number ng oxygen natin ay 8. So, you cannot tell exactly where those 8 electrons are located in an electron cloud model or quantum mechanical model. But you can tell how many electrons are there. But hindi mo masasabi kung nasaan sila exactly, even their direction. So, this is the modern atomic theory. Schrödinger and Heisenberg showed that electrons do not travel in definite paths. Ibig sabihin, hindi eksakto yung location nila, yung papatunguhan nila, yung direction nila. So, when people still think that atoms look like this instead of this, Werner Heisenberg is very much disappointed. Then we also have here James Chadwick. In 1932, he discovered the neutron through this experiment by using a polonium source that is bombarded in the beryllium particle na mayroong paraffin and mayroong gauger counter na nag-measure nung impact ng bombardment which is 1000 voltage. Doon niya na-discover yung uncharged particle na si neutron because that time nagtataka sila saan galing yung unknown mass doon sa gitna nung isang atomic model. So, saan gagaling yung mass? Ang nomination nila yung protein, yun lang yung mass na napaperceive nila. Very less. But then there is an unknown mass or uncharged particle na mayroong nag-contribute ng mass dun sa gitna. Na nag-concentrate ng heavier mass dun sa gitna. So, dito ngayon na-discover by measuring it using a Geiger counter at 1000 volts. So, Chadwick is a discoverer of neutron. He was a student of Rutherford, who is a discoverer of the proton. But then Rutherford was the student of Thomson, the discoverer of electron. Then we have here the history of the atom, theories and model. First, we have the Aristotle, his 4 elements, and then we also have the Democritus and Leucippus, coined the word atomus, the first idea. Then we have here the John Dalton, with his billiard ball model of atom or also known as solid sphere model in 1803. Then next, we have J.J. Thomson, plum-pudding model at 1904. Then nuclear model by Ernest Rutherford at 1911. Then planetary model by Niels Bohr at 1913. Then quantum model or electron cloud model of atom by Erwin Schrödinger and Werner Heisenberg. Huwag yung kakalimutan si Werner Heisenberg because Werner Heisenberg is the actual proponent of the quantum mechanical model. So Erwin Schrödinger, yung sa kanya lang kinuha yung idea or inspiration dun sa model. Ang idea dun ni Erwin Schrödinger ay yung wave-particle duality in terms of position momentum uncertainty. But then, the proponent for quantum mechanical model or electron cloud model is Werner Heisenberg with contribution of Erwin Schrödinger. So that is all for the history of atomic theory or atomic models of atom. As we can say, the atoms or the development of the atomic model is largely dependent on the evolution of technology as well. Okay, so that is all.